I wonder how many of these cities you recognise. Can you see the one where you live, or maybe even the one where I live? They're all very different, aren't they? I'm going to talk about cities and climate, and the way that the climate interacts with our cities. And first I'm going to talk about actually how all our cities share a lot in common. They all have large populations. They are all densely built. They need a lot of water resources and use a lot of energy. They have a lot of industry and a lot of infrastructure. They're often heavy in tourism and based near to coasts and rivers, but they're also unique in the way that they interact with the climate. Scientists from the UK and China are working together in partnership to develop new science to help us understand how cities interact with the climate, and in particular how we can help science benefit society. I'm going to talk about a few pieces of science which have been developed between the UK and China. Firstly, scientists are looking at how we can observe the climate, and in particular past climates. You may ask, why are we interested in the past climate? But in order to understand our current climate and the changes we're seeing now and the changes we might see in the future, we need to understand what's happened in the past. So we're looking at historical data sets which so far have been hidden in the logbooks of ships or in remote stations. And these are being digitized so that we can look at more data to see how the climate has changed in the past and fill in some of the gaps currently in our records. So interpreting historic data sets helps us to understand what is happening to the climate and our cities now. We can also take a more high-tech approach, and scientists are looking at how we can analyze new satellite data to understand our cities better. The animation on the right here shows changes in the heat island in Shanghai and how intense heat has been changing over the years as the city has been developing. Even more importantly, the animation on the left shows the same thing at night. It shows how there are particular hotspots within the city where the city doesn't cool down at night, which can be important for human health as our bodies don't get the chance to recover, and this can lead to heat stress. So we're using satellite data to get a better view of how the influence of the climate on our cities is evolving, and city planners can use this to adapt. We're also looking at how the climate might be changing and how the influence of humans on the climate can be seen. You may remember this cold event in January 2016, which affected millions of people in China. Scientists are using climate models to understand whether the probability of such an event has changed already due to climate change. And they've concluded that human influence has reduced the probability of such a cold event already by approximately 2/3. We can also look at heavy rainfall events. This caused massive impacts in southeastern China in 2017. And scientists have found that human influence has approximately doubled the chance of such an event happening. But what about extreme events that we haven't seen yet? Scientists are using climate models to run simulations of the current climate which are realistic but contain extreme events which haven't actually happened yet. For instance, they found that there's a 10% chance of unprecedented heat waves occurring each summer. This is useful as it allows planners to plan for things that haven't happened yet, but which are possible. So using climate models, we can understand how climate risks experienced in cities are changing. Finally, I want to talk about typhoons, which are particularly relevant at the moment for cities in eastern China and southern China. UK and Chinese scientists are working together at the moment to understand what is the worst typhoon possible, and they're focusing on the worst typhoon that could hit Shanghai. These simulations show typhoons from the past, historical typhoons which have been experienced, but put into future conditions under climate change, where we expect that typhoons might become more intense. And these model simulations show that indeed these typhoons produce more rain and are more intense than typhoons that we've seen in the current climate. We're working together with decision makers to understand how the science being done can influence their decision-making and help make more robust decisions. For instance, the energy industry are interested in typhoon conditions which could damage wind turbines, but could also produce more electricity. So working with decision makers, we're trying to provide climate information which will help cities respond to climate challenges. In conclusion, cities are unique and uniquely influenced by the climate. New science being done in collaboration is helping us to understand how our cities are influenced by the current and future climate. Working closely with people making real decisions means our science can have a positive impact on society.